All right, so the last couple of methods are not as trivial as the other three, the other ones that we did move, since those were trivial, since they were using a common denominator, right, for representing the time, the duration, as in seconds. So we're going to be using a technique called the factory method design pattern, right? That is going to use the idea that sometimes, right, you want to be able to decide at runtime. You want to be able to decide which implementation you're going to use, right? Depending on the way it's being used, depending on flags, depending on some logic. You say, ooh, the better way to represent them is using this particular implementation or that other implementation. So that logic, right, is best to centralize in one place and make a decision on which implementation, what representation you want to use, right, at runtime, right? So that design pattern of deciding which instance to use, right, based on some criteria is what we refer to as the factory design pattern, right? You instantiate, you factor, you create instances based on some logic, as opposed to you explicitly instantiating something, right? Instead, you delegate it to some logic. Right, and based on that logic, you instantiate one instance or another instance. So let's take a look at that. Let's take a look at the plus operator. Right, the plus operator inside of the duration impl. Right, that implementation looked at this implementation. Right, it did plus. It was adding two instances. Right, the current instance plus something that you were passing. And the implementation was to convert them both into integers and then reinstantiate a new instance, right, that had the same output value. Yes, and that's fine, right? For that implementation, it's okay. The only problem here, the problem with this implementation is that we have duration impl hard coded right here. Okay. And so it's hard to move it outside, right, and move this to a different class where you don't have duration impl, right? That you're moving it up to an abstract implementation, right? And the whole point is that we're trying to eliminate dependencies on any particular implementation. If this instead would have been perhaps the base interface, perhaps we could have gotten away with this, right? But we don't have a concrete, right? So it's an interface. It doesn't have a constructor, right? So how do we do that? So we have that implementation. So that's a problem. Right? That's a problem because we have the constructor right there, hard coded. Right? And if we move it over. Right, if we move it over to the abstract implementation, it's always going to return that particular instance. Yes?
What's the need to abstract this method if it's very specific to this implementation? Why can't you just leave it and make the abstract class just have an abstract method plus?
Well, the problem is that we also have a plus implementation on the other compact class, right? And they look almost identical to one another, right? So what we're trying to eliminate here is identify where there's redundancy. And factor it out into one single place, right? So this is very similar to the implementation we would have to implement on the other side, right? So if we factor it out and move this particular implementation over to the abstract class, right? The problem is that if somebody calls the plus, what they're going to get back as an instance, right, is always the duration impl, an instance of a duration impl. So even if they were using a compact implementation and they pass it in. Right, what they get back as a response is something that is of a different instance, right, of a different type of what it is that you passed in as an argument, right? So that's going to be a problem, right? Instead, what we'd like to be able to do is see if we could have the plus sign, right, determine which one is it, right? If I was somehow adding instances of duration impl, I should be able to use the original duration impl. If I'm using instances of the compact representation, then I should be adding instances of the compact implementation, right? But that decision should not be done at the abstract level, right? it should be delegated to each one of the classes. So we need a mechanism. We need a mechanism that we can centralize the plus operation, but delegate down to our children which actual instances to use. Depending at runtime, whatever we actually have in memory, right? Whenever we're past an actual instance, right? So we're going to have each class decide what to choose instead of any particular implementation. So let's look how we can do that, right? So what we're going to do is that we're going to move over onto the abstract class. What we're going to move over is something that looks like this. Okay, we're going to do the plus that is only defined in terms of the interface, right? And it's going to and what we're going to do is that we're going to create a function that at runtime is going to decide whether it should return either an instance of the duration impl, or it should return an instance of a compact duration, right? At runtime, depending on what you pass here, right? I'll make a decision to use one or the other, right? And we're going to grab that logic, right? And we're going to put it inside of fromSeconds. Right? So fromSeconds is going to decide which one or the other, okay? And that technique of delegating the decision of whether you're going to return one instance or another instance, right? That principle, right, is called factory pattern, the factory design pattern, okay? All right, so there it is. So there's fromSeconds, right? So what is this fromSeconds? Who implements this fromSeconds? Let's take a look at that. Okay. What we're going to do is that we're going to declare a brand new method called fromSeconds, right? It'll be abstract. It won't be implemented at the abstract class. Instead, it will be implemented down at the children. The children will know, right, whether it'll has to return one or the other. Yes.
It's dynamic dispatch.
Yeah, exactly. Yep. Depending on the type, right, of each one, we'll use one or the other.
Also, if you're making a fromSeconds in each of the classes, doesn't that kind of get rid of the point of having it be unified among?
Well, no, what we're trying to do is that clients, right, when they compile against duration, right, they're using the abstract version, and they want to call the plus, and they don't want to get back something that is of a different type, right? That they want to get the right type of whatever they were actually using from when they were instantiated the first time, right? So we're moving it over, but then we're delegating that decision down to the children. Yes. I'm sorry. Yeah, exactly. So that's what we're going to do, right? But we're not going to have the abstract decide those kinds of things. We're going to delegate that to each one of the implementation classes, right? So that we will be free now. If we put it in the abstract, then if tomorrow we want to have a brand new implementation, right? We would have to edit the base abstract class. Instead, we would be free to leave that abstract class and just create any number of additional implementation classes, right, as long as we implement that particular decision on how to define which instance to return. Yep. Right. So we're going to go we're going to declare the fromSeconds as our factory method, right? It's not going to be implemented in the abstract class, right? We're going to declare it as an abstract method, right? And instead let the children, right, create that implementation. Right? Notice that we have the abstract duration, and notice that our fromSeconds, right, it's abstract, right? We're not implementing it here, right? It doesn't have an implementation, and notice that it's protected, right? We're saying that only my children, right, will have access to this, right? Only my duration impl, my compact duration, only those will have access to this particular method, right? And reducing the accessibility, right, to only parent-child relationship. Yes? Yes?
Protected also mean that like any children of the children can access it too, and it's like everything downstream of it?
That they inherit from that. Yep, exactly. Yep. So we make it available to our children. Yeah. So what fromSeconds is right. It's protected. The concrete classes when we declare it as abstract, right, when we declare abstract, it's just the same as if we were declaring at an interface, right? Anybody who's implementing this abstract class, whoever is extending this abstract class is obligated to provide an implementation, right? Very much like when you implement an interface, right? The implementing class is obligated to implement all those interfaces. It'll be, it will be a compile error not to go in and provide implementations for these methods. And then so each one of the concrete classes, right, will decide what is that they should do. Right? They'll provide the implementation. So we'll delegate it to the children to decide. So here it is in duration impl, right? It does the right thing, right? When you pass it the seconds, right? It returns the correct type, right? And then obviously it's casted up to the duration. Obviously, now you know that you'll get the right instance. Typically, that's all they do, right? They return just an instance of themselves, right? Of using the correct constructor, right? That converts from whatever you pass it, whatever raw data you pass it. Oftentimes, these not only do they pass raw data, they might also pass in some configuration parameters, right? That might drive the logic in here, right? And depending on that logic, you might make some decisions on what is to do. Here, the strategy is that depending on how you use it, depending on what you pass me, I do one thing or the other. I use the one above or the one below, depending on the type, right? But factory patterns could also pass optional flags or optional enumerated data types or other parameters, other meta information, right, that could drive the logic on implementing and instantiating the correct type. So now it looks like this, right? We moved over the plus. We moved it over to the abstract duration. We declared a fromSeconds. Notice it's italic. It's italic meaning it's abstract, right? I'm not providing implementation here. And notice that it's protected. We have the hash sign over there. But we are providing the fromSeconds, right, actual implementation in each of these down below. And so basically we're delegating it to the compiler, right? The compiler will decide which one to use, depending on what it is that you pass, the correct type that you pass in the plus. Depending on what you pass in, it'll decide to use one or the other. If you pass in the plus duration, if you pass in a duration impl, then it'll use this one, right? Whereas if you pass in a compact duration, right, fromSeconds will use this implementation. Yeah. Right. So this is idea of the factory design pattern. It's very common in especially on server-side technology. When you're programming, it's very common that the factory design pattern is used very heavily. Right. That it's very rare. Well, not very rare. It's very common that instead of you instantiating something using new and then the name of a class, it's very common that there will be some factory, right? That you instantiate first the factory, and then with that factory, then you pass in some parameters to the factory and says, okay, give me a new instance of this thing, right? And then what you get back is instances of different classes that are assigned to variables of some interface, right? So that you're delegating all that logic of deciding what instance to use. You're delegating all that to some methods that are going to figure out what instance to give you back. Okay. Again, it's a very common design pattern in industry today. Right. So in this case, the case that we're using it here is based on how it's being used, the use case. We're deciding which to instantiate, but it's very common that you pass additional arguments, right, to these factory to configure what it is that you're passing. But we still have some redundancy. Let's revisit some of the other functions that we have, methods that we haven't looked at yet.